Hi, John here. In this video we're going to be looking at the fire tube boiler, also known as a smoke tube boiler. And normally in our videos what I do, I run through things like the components, the parts, how they work and things like that. But in this video I thought we'll take a different approach. Why don't we build a fire tube boiler together, and that way we can understand why it's built the way it is and how it works. In order to do this, we need to be a little bit creative, and that's why we invented the configurator tool. Now I absolutely love this tool, and I'm going to show you what it does right now. So here's our fire tube boiler. I'm accessing the fire tube boiler directly through a web browser, and if you check the video description area, you'll be able to access this 3D model through your web browser as well. You just click on the link provided. So what is the configurator and why is it so good? Well, let me show you. Here's our configurator, and as you can see there are some names here on the right hand side, and there's an eyeball, and if we cross out the eyeball we'll be able to hide and show different parts of the boiler. Let me show you how that works. Let's take a cross section first. So we can see here, we can see inside the boiler, and we've also got some arrows, and the arrows are going to allow us to see the direction that the exhaust gas is passing through the boiler. If we go back to our full view, we can remove parts like the cover, for example, and if we go down we can remove the shell, and then we can have a look at some of the parts inside the boiler. Maybe we'll go down a little bit further, we can remove some of these tubes that are kind of in the way. Maybe we'll get rid of some more tubes, and we can actually see what's going on inside the boiler. So the configurator is a pretty cool tool. In fact, it's probably one of the best things about saVRee and the thing I like the most. So check out the link in the video description area, and you can do everything I'm doing direct through your web browser, and it's really going to help you to learn. But as I said before, what we're going to do is build a boiler. So let's just reset the configurator for a moment, and we've got our fire tube boiler here. Like I say, it's also known as a smoke tube boiler. We are going to do a video for a water tube boiler, but that's going to come a little bit later. So let's go up to the top. In fact, if we go back down, we can reverse everything, and we can see that we've actually just got an empty space. So in my factory, I've got this empty space and I want to build a boiler there. So the first thing I need to do is to add some supports. So I'll mark out the area where I want to build the boiler. So there it is, this red frame. Next thing I should do probably is to add a shell. We'd actually put the cover around the shell. The cover is sort of like insulation, and the cover would go around the shell. So let's just do that for a moment. I'll take it off in a second. So we've got the cover around. It's normally a bit thicker than what we're seeing here. And the idea with the cover is that we insulate all of the shell in order to trap the heat inside the boiler, or as much of it as possible. We don't want to lose the heat because we're paying money for combustion and for fuel and things like that, which we're going to learn about in a moment. So we'll insulate the shell and consequently the boiler. So we've got our shell. We're going to fill this up with water, because the idea with the boiler is that we can burn some fuel and we can heat up some water and we can turn that water to steam. So let's imagine for a moment we try and fill up the shell. Well, that's not going to work out too well for us at this present moment because the water is just going to run out of the shell. So let's start thinking about what else we can add here. We're going to need a burner. We're going to need something to create combustion. We're going to be burning things like light fuel oil and gas. So let's add our burner. Okay, so the burner's there. We've got a bit of a problem now because if we were feeding fuel into the burner and we're also feeding in air in order that we can have combustion, remember you need heat, fuel and air, or heat, fuel and oxygen in order to get combustion. That is a fire triangle. So if we feed all of that in, then we've actually just got it going into our shell, and that's full of water. Well, not really, because it's leaking quite a lot, but this isn't really going to work out very well for us. So let's add some more parts here for a moment. We'll add a corrugated furnace, and we've still got a bit of a gap here. So let's just see what else we can add here. Maybe we'll go down. We'll add something called a smoke box. we've kind of filled the gap up a little bit now. We've added 2 ends onto our cylinder. There you go, we've got another end here. This is actually the smoke box on the end here. We'll discuss that in a moment. If we go down here, okay, so we've sealed off the furnace. So we've got our fuel going to the burner. We've got our air being drawn into the burner, and we'll ignite the fuel, and we can then have combustion in the furnace, which is going to be this area here. This is actually a corrugated furnace. Let's take away the shell for a moment. So you can see it's got quite a unique shape, long and cylindrical, and this is known as the corrugated furnace. Let's actually just go inside for a moment. We can have a look. So we are inside. We've got our burner down the end. We're going to have combustion in this space here. So we're going to have a flame. It's going to be burning around here, and the exhaust gas is then going to be pushed further away from the burner. So we're traveling away now. If I go out, we've actually just came out of the boiler, but we get to the end of the corrugated furnace, and then we've got the same problem as before. We're just sort of ending somewhere in our shell, and we're surrounded by water again. Okay, so that's not very good. Let's add a reversal chamber or reversing chamber, and you can see we've sealed off that area now. The exhaust gases are going into reversal chamber. And then what's happening? Well, if we zoom out, we can have a look around the other side. It's actually sealed on this side as well. There are no holes or anything. The only place where there are holes are on this side here. So we've got the holes, and they're coming out of the reversal chamber. But now what? Well, that's still not very good. We're still just going to end up with a lot of water splashing around, because remember, our shell, which seals the whole thing in, should be full of water. Let's get rid of that shell again. So now what we need to do, we need to get the exhaust gas from here, from the reversing chamber, or the reversal chamber, and we need to get it out through the smoke box. You actually see a connection here. That's going to connect to a chimney, and in order to get that exhaust gas to the smoke box on the end, we're going to have to send it from the reversing chamber all the way over to the opposite side. So let's do that. I'm going to need to add some tubes here. This is why we call it a smoke tube boiler or fire tube boiler, because we're literally sending the smoke through tubes in the boiler. The water tube boiler, as the name implies, has tubes that are full of water, and the smoke tube boiler has tubes that are full of smoke or exhaust gas. So let's add our tubes. Okay, so the exhaust gas is coming out of the reversing chamber, coming along here from right to left, and then once again we're going to hit loads of water. Right, so let's solve this issue. We need a front tube sheet. So there's our front tube sheet, and now we've got the exhaust gas coming out of these holes here, and also in this section here. And we need to turn that exhaust gas around and send it back through these holes here on the outside. Now normally, if we add some inspection doors, we can seal off this section here, and we can seal off the smoke box, which is this section here. We can't really see much when we add the inspection doors or inspection hatches, so let's just remove those again. So the exhaust gas is coming out of these tubes here, and then we're going to try and turn the exhaust gas and send it back through the tubes here. Unfortunately at the moment we don't have any tubes, so let's add those tubes in right now. Third, smoke tubes. Okay, so we've got the exhaust gas on the left. It's traveling now to the right, all the way to the smoke box here, and then we've got another problem. These tubes are not really sealing with the smoke box very well at the moment. So let's go down here. And what I was actually looking for was a back tube sheet. Normally I refer to this as a rear tube sheet, but here it's a back tube sheet. And as you can see, we've sealed off those tubes now, and the exhaust gas is going to flow out of these tubes, the third pass of tubes. It's going to come into the smoke box, and then if we angle this correctly, we should be able to see where the exhaust gas exits, and it's going to go through the exit at the top here, spin around, and go to the chimney and to a stack. So we've got rid of the exhaust gas, and as you may have noticed, it passed 3 times through the water that would be within the boiler. So this is a 3-pass boiler. Let's look at the first pass. We go from the burner along the furnace to the reversal chamber, and that is 1 pass. We'll then add our second smoke tubes. The exhaust gas comes along here, and that is our second pass. We'll then add our third smoke tubes, and we have our third pass, which goes left to right. And then the exhaust gas has transferred a lot of that heat to the water, which is going to turn some of the water to steam. And the steam is going to collect at the top of the shell. The entire shell is not full of water. The water level would actually be somewhere around here. We want to submerge all of the tubes in water, and we want to make sure they're totally immersed in water, and that at no point does the water level reduce to a point where the tubes are not covered in water. If the boiler is in service and there's hot gas flowing through these tubes, the tubes have to be submerged or immersed in water. Otherwise, you risk fracturing the tubes or breaking the tubes, and you may have a boiler failure. Let's add the shell again, because I just want to show you how the boiler looks when it has a bit more of a simple construction. So we can add the shell. Let's just take off a few bits and bobs for a moment. We know about the burner. We know we need a source of combustion. Let's take off the ends. And you can see we've actually got quite a simple design now. It's just a long cylinder, more or less. So we've got a cylinder. We fill up the cylinder with water. We've sealed the exhaust gas system, so it's not going to mix with the water. And once we fire up the boiler, we allow the exhaust gas to pass through the furnace and the tubes, etc. Then we'll transfer the heat to the water, and we will turn it to steam. But as you can see, the boiler design is relatively simple when we break it down into its major components. But let's just reset everything for a moment. We'll take a cross section so we can see some of the arrows. And we can actually just go inside our boiler a little bit here. We can see that the furnace, the corrugated furnace is here. The red arrows are going left to right. The red arrows will then reach the reversal chamber, which if we angle this correctly, we can probably see. There's the reversal chamber here. We'll spin the exhaust gas around, send it back the other way. And then when it gets to the other reversal chamber at the opposite end, we'll spin it around once again. If we come around this way, we can actually see that occurring. You can see the exhaust gas comes out of these inner second pass tubes. So those ones here. We'll spin it around, send it into the third pass tubes on the outer periphery of the boiler, or closer to the shell. And then, as we can see, it comes left to right. So left to right for the corrugated furnace, right to left from the reversal chamber to the other reversal chamber, and then left to right again, all the way to the smoke box. And if we go along here, we should be able to see that. You can see the tubes connecting here. They're going through the rear tube sheet into the smoke box, and then the exhaust gas will exit to the chimney. So that's essentially how a fire tube boiler works. I hope you enjoyed this video. I hope you enjoyed having a look at our new fire tube boiler. I hope you enjoyed the configurator tool. I think that's one of the best things we've got on saVRee at the moment. And I really do encourage you to go and check out the link in the video description area. Click on that link. You can do exactly what I'm doing now on your smartphone, on your PC, on your laptop, on your Apple Mac, whatever. And if you're using this tool and you're watching this video, then you really should be able to understand exactly how a fire tube boiler works. And that's what we're all about at saVRee.com. We want to give you the tools that you can use to learn about engineering effectively, and I really do believe this is one of the best tools out there. So check out the link. If you've got any comments about this video, maybe you've got some suggestions of what we can do next, maybe you visualize in your mind that we can use a configurator for things like electric motors, heat exchangers, turbines, whatever, add your comment to this video and I can guarantee you that we will read these comments and we really do appreciate your feedback. If you like this video, then please do share it on social media or subscribe to the YouTube channel. And if you want to learn more about engineering related topics, then we've got over 30 hours of engineering video tutorials, much like this one. So check out links in the video description area. I'll paste a coupon into the video description area as well. So check all those links out. Use the coupon if you decide to sign up for any of our courses. And I hope to see you on another video lesson very soon. Thank you very much for your time.